Earthquakes don't just shake the ground, they rewrite the world. In seconds, entire landscapes transform. Mountains rise, rivers shift, coastlines vanish. Welcome to Faultline Fracture, Quakes Reshape Maps. Today, we explore how earthquakes alter the planet's surface. Why do these changes happen, and what do they mean for us? Stick around to find out. Let's start with the basics. Earthquakes happen when tectonic plates move. These massive slabs of Earth's crust float on a molten layer below. When they grind, slip, or collide, energy releases as seismic waves. That's what we feel as shaking. The United States Geological Survey, or USGS, tracks these events globally. Over 1 million quakes occur yearly. Most are minor, below magnitude 3, but the big ones, they leave lasting marks. Earth's surface is always changing. Tectonic plates shift about 2 to 10 centimeters per year. That's roughly how fast your fingernails grow. Over millions of years, this movement builds mountains, opens valleys, and redraws continents. Major earthquakes speed this process up. In moments, they can shift landmasses, redirect rivers, or even change maps. Let's look at some examples to understand how this happens. First, the 1964 Alaska earthquake. At magnitude 9.2, it's one of the strongest ever recorded. On March 27, 1964, the Pacific Plate lurched under the North American Plate. The ground shook for nearly 5 minutes. Entire towns slid toward the sea. Prince William Sound's coastline lifted by up to 11 meters in places. That's taller than a 3-story building. In other areas, the land dropped, flooding coastal zones. The quake reshaped Alaska's geography permanently. New inlets formed, islands shifted, maps had to be redrawn. Another example is the 2011 Tohoku earthquake in Japan. This magnitude 9.0 quake struck off the coast on March 11th. It shifted Japan's main island, Honshu, by about 2.4 meters eastward. That's roughly the length of a car. The ocean floor also moved, triggering a massive tsunami. But here's the kicker. The quake altered Earth's rotation slightly. NASA, National Aeronautics and Space Administration, calculated it shortened the day by 1.8 microseconds. The land movement was so significant that satellite maps needed updates. Coastal areas sank and new shorelines emerged. Smaller quakes can also reshape landscapes. Take the 1992 Landers earthquake in California, a magnitude 7.3 event. It cracked the Mojave Desert surface, creating new fault scarps, visible cliffs where the ground split. Some scarps stretched over 70 kilometers. That's like a new geological feature longer than Manhattan Island. These changes forced surveyors to adjust local maps. Earthquakes don't just move land, they redirect water. In 2004, the Indian Ocean earthquake, magnitude 9.1, shifted the seabed off Sumatra. This triggered a massive tsunami that killed over 230,000 people. But it also changed river paths and coastal wetlands. In some areas, the land rose, draining lagoons. In others, it sank, flooding fields. These shifts altered ecosystems and required new topographic surveys. More recently, the 2023 Turkey-Syria earthquake, magnitude 7.8, struck near the East Anatolian Fault. It displaced roads and rivers by up to 7 meters. Entire valleys reshaped. Local maps became outdated overnight as fault lines carved new patterns into the earth. Earthquakes reshaping maps isn't just a cool fact. It has real consequences. First, there's infrastructure. When land shifts, roads crack, bridges collapse, and pipelines rupture. After the 2011 Japan quake, highways moved meters, misaligning transport networks. Rebuilding meant resurveying the land. Cities had to adapt to new ground realities. Then there's navigation. Modern maps rely on Global Positioning System, or GPS, data. When quakes shift land, GPS coordinates change. This affects everything from car navigation to disaster response. After the 2010 Chile earthquake, magnitude 8.8, coastal shifts forced updates to nautical charts. Ships needed new routes to avoid submerged hazards. Ecosystems also feel the impact. When rivers change course, wetlands dry up or flood. Wildlife habitats shift. The 1964 Alaska quake turned coastal marshes into uplifted plateaus, displacing marine life. Farmers and fishers lost livelihoods as land and water boundaries changed. For scientists, these changes are a gold mine. Geologists use quakes to study Earth's crust. Each fault line fracture reveals new data about tectonic plates. The USGS and other agencies update models to predict future quakes. This helps save lives. For example, after the 1992 Landers quake, researchers improved fault maps, leading to better building codes in California. There's also a human angle. Redrawing maps isn't just technical, it affects communities. When coastlines shift, people lose homes. When rivers reroute, villages relocate. The 2023 Turkey-Syria earthquake displaced thousands as land cracked beneath towns. Updating maps helps governments plan recovery, but it also reminds us how fragile our place on Earth can be. Finally, earthquakes challenge our understanding of permanence. We think of mountains and rivers as fixed, but earthquakes prove they're not. They force us to rethink how we build, plan, and live on a dynamic planet. Maps aren't just lines on paper, they're snapshots of a world in flux. Earthquakes do more than shake us up. They reshape the planet. From Alaska's uplifted coasts to Japan's shifted islands, quakes rewrite maps in seconds. They move mountains, redirect rivers, and even tweak Earth's spin. These changes affect infrastructure, ecosystems, and communities. They push scientists to learn more and help us prepare better. Next time you feel the ground tremble, remember, it's not just a quake. It's Earth redrawing itself. Thanks for watching Faultline Fracture, Quakes Reshape Maps. If you found this fascinating, hit that like button and subscribe for more stories about our planet's power. Drop a comment. What's the most epic quake you've heard about? See you in the next one.